Welcome to part 2 of the AI Literacy series. In this session, we will tackle a question many leaders will ask. What happens when AI models stop performing as expected? In part 1, we look at how AI can predict lead time. Today, we shift to the operational reality. What happens when conditions change, data evolves, and model begins to break down? To keep this practical, I will continue using lead time predictions as a running example and explore this challenge from a supply chain perspective. My name is Farine. I'm a supply chain professional and I'm passionate about helping people to understand how to apply AI responsibly and effectively in the real world operations. Every AI model breaks eventually. The only real question is whether the organization is prepared when it happens. What we call model drift is actually very simple. The model learns patterns from the past, but the world has moved on. In this example, the AI was trained on 2023 data, but is now 2026. Trade routes, suppliers, costs, behaviors all have changed, the model hasn't. There are two common ways this shows up. First is data drift. The inputs has changed. For example, new suppliers, new lanes, new regions, or new order profiles. Second is concept drift. The inputs may look the same, but the outcomes have changed. The same supplier or route behaves very differently than before. This mismatch is not a technology failure, it's a business reality. The risk is not that drift happens, but it's not noticing it early or not knowing what to do next. When a model starts underperforming, it's tempting to think something is wrong with the AI itself. In reality, breakdowns usually follow very predictable patterns. One pattern is sudden external shocks. Trade restrictions, labor actions, or global events can disrupt specific routes or suppliers overnight. In those moments, the right response is not to fix the model, it's to protect operation first, then recalibrate once the environment settles. Another pattern appears during growth. When the business expands into new suppliers, regions, or product lines, the model simply doesn't have enough experience yet. That's not failure, it's a coverage gap. The solution is temporary buffers or targeted retraining once enough data accumulates. A third cause comes from inside the organization. Processes like new ERP systems or procurement policies can quietly alter how data behaves. The model still sees the same fields, but their meaning has changed. This often requires revisiting features, not just refreshing data. Finally, there's plain aging. Even without major shocks, models slowly lose relevance as conditions evolve. This is why mature organizations treat retraining as routine maintenance, not an emergency response. When AI models fail, they rarely announce it directly. Instead, the first signals usually appear in operations. One early sign is inventory behavior that no longer makes sense. For example, stockout increase, safety stock feels off. Yet teams can't trace the issue to supplier quality. When this happens repeatedly, it's often a planning signal problem, not an execution one. Another red flag is what I call robot mode. The model keeps producing the same answer over and over, regardless of supplier, route, or order size. That usually means the model has lost sensitivity to real-world differences. A third signal is when the model becomes disconnected from reality. Whether disruptions, strikes, or seasonal effects are happening, but predictions remain unchanged. That tells us that the model is no longer responding to meaningful external signals. Finally, watch out for instability. If predictions swing wildly within days with no business explanation, confidence in the model should drop immediately. Stable systems may be wrong, but erratic systems are dangerous. The rule of thumb is simple. If you observe more than one of these signals at the same time, do not debate, investigate. When leaders ask whether an AI model is still healthy, the answer should never be technical. It should be visible through a small set of business-facing matrices. The first is prediction accuracy. It's not perfection, but stability. If we see accuracy drifting below an agreed baseline, that's an early warning that decisions are increasingly misaligned with reality. The second metric is error magnitude. In plain terms, how wrong we are on average. A model can still look accurate, but become meaningfully worse in practice if errors double. This directly translates into buffer inflation, expediting, and service risk. The third is data quality. This is often overlooked, but that's the foundation. Once completeness or correctness drop, the model may still produce confident outputs, but just based on faulty inputs. That's where risks become invisible. What's important is not who monitors what. Your data and analytics team should track this daily. Leadership should focus on trends and not noise. through short weekly checks and a deeper monthly review. This keeps AI governance lightweight, predictable, and aligned with how executives already review financial and operational performance. Monitoring AI does not mean watching everything all the time. It means putting the right signals at the right level of the organization. At the top levels, leaders should focus on outcomes, not mechanics. For example, are predictions staying reliable? Are planners still confident using them? And are we seeing downstream impacts in inventory, service levels, or expediting costs? One layer down, the system needs automated health checks. This is where models are quietly assessed by segment, drift is detected early, and data quality issues are flagged before they surface as business problems. At the base, there must be real-time alerts for critical failures, such as suddenly accuracy drops, key suppliers being affected, or data pipelines breaking. This layer exists so people don't discover issues through operational pain. Just as important is clarity on ownership. Executives should see a short money summary, supply chain leaders review trends weekly, and the data team handles daily monitoring and alerts. The objective is simple. Problems should be detected in days, not discovered months later through firefighting. One of the biggest mistakes organizations make with AI monitoring is over-engineering it. More matrices does not mean better control, they usually mean confusion. At a minimum, leaders should insist on a few fundamentals. Firstly, is the overall accuracy holding up against its baseline? Are there specific suppliers, lanes, or modes where performance is degrading? And most importantly, is the data still complete and trustworthy? Another simple but powerful check is the shape of predictions. If the model suddenly produces unrealistic or overly narrow ranges, it's often an early warning, even before accuracy drops. Beyond that, there are many advanced diagnostics teams can run, such as feature drift, confidence calibration, and correlation changes. What leaders should actively avoid is noise. Large volumes of technical matrix, real-time dashboards that nobody acts on, or measures that planners cannot interpret. The cadence matters more than the complexity. Data quality should be checked automatically and frequently. Model performance review weekly, and once a month, leaders should step back and ask whether the model is still aligned with how the business operates today. When drift is detected, the goal is not to react quickly, but to react correctly. Most issues are not model failures, they are data or process issues, so we always check those first. If the change is real, we assess impact before acting. Sometimes the right decision is to wait. Only then we decide how far to go, to adjust logic, limit usage, retrain, or rebuild. The most expensive option should always be the last resort. This slide shows how mature teams respond to a model drift over time. In the first few days, the focus is diagnosis, confirming whether the issue is real and whether action is needed at all. If a fix is required, retraining or recalibration typically takes weeks, not days, which is why operational protections must happen in parallel. That's why rollback, interim rules, or controlled rollout start early while the technical fix is underway. AI incidents are managed like any operational risk. Diagnose fast, protect immediately, and fix properly. Once drift is confirmed, the response depends on what actually changed, not on a fixed playbook. In most cases, the issue is either data quality or business expansion. That's why the most common path is, firstly, check the data, understand the change, retrain with updated data, and roll out gradually. That typically takes up a few weeks and a moderate investment. And most importantly, it avoids overreaction. What matters most is sequencing. We always protect operation first, then fix the model properly. Rebuilding from scratch is reserved for major structural changes, such as new ERP systems, new operating models, and that is not for everyday drift. Let me close with a few leadership takeaways. Firstly, drift is not a failure, it's normal. AI systems require ongoing care, just like ERP or planning tools. Leaders should expect and budget for maintenance, not treat it as an exception. Second, timing matters more than sophistication. Problems detected early are far cheaper to fix. The same issue costs exponentially more if discovered months later through operational pain. Third, data quality is the first place to look. Most so-called model failures turn out to be data issues. Retraining without fixing data simply repeats the problem faster. Fourth, protecting operations comes first. You need a short-term fallback while the model is still being fixed. Otherwise, trust is lost before the solution is ready. Fifth, most cases are not complex. The majority resolve with disciplined retraining. Over-engineering is usually a leadership decision, not a technical one. Finally, communication matters. Regular updates keep teams confident in using AI, and silence is what causes people to abandon it. This slide is about leadership readiness, not technical detail. Before anything breaks, leaders should know, first, do we have visibility? How fast can we respond? And what's our fallback? When drift happens, the focus should shift quickly to business impact, not technical debates. Strong teams answer with dashboards, timelines, and clear actions. Weak teams rely on hope or assume the model will just work. These questions help leaders distinguish governed AI from unmanaged AI. To make this practical, there are three time horizons leaders should focus on. In the immediate term, such as this week, the goal is awareness. Do we even have the visibility into drift? Do we know what normal accuracy looks like today? And if the model fails tomorrow, is there a document fallback? Over the next 30 days, the focus shifts to structure. Set out a simple monitoring view, define a response playbook, and be explicit about ownership. AI incidents fail mostly due to unclear accountability, not technology. And for ongoing, the objective is prevention. Quarterly retraining reduce surprise, and money reviews surface issues early. And then documenting lessons ensures the organization gets better each time instead of repeating the same fix. This is how AI moves from experimentation to an operational capability. This session provides a high-level overview about model breaking and how to handle model drift in production. Many topics shared today, such as types of model drift, can be a deep dive on their own. Before we close, I'd like to briefly share what's coming out in the next AI literacy series. The next topic will focus on how to use AI responsibly and ethically, especially in supply chain decision making, where AI is increasingly influence cost, service, and risk. I'm also consider a follow-up session that explains step by step how to respond when data drift occurs in a production model. If there are specific areas you'd like to explore in depth, please let me know. If you have questions or reflections, feel free to share them in the YouTube comments. I'll be checking in and continue the conversation there. For more detailed discussion, you can also reach out to me by email or connect me on LinkedIn using the QR code on screen. I'm always happy to exchange ideas with fellow supply chain professionals. Thank you for your time, and I look forward to staying connected as you explore AI in your work. Bye.